Hey, Miss Lisensky here. I just want to introduce the greenhouse effect a little bit. We will just learn a little bit the basics of how it works in this unit, and then later in the year when we do an entire section on climate change, we'll get much deeper into the greenhouse effect. But I just want you to have a basic understanding of what the greenhouse effect is, and then in the rest of this lesson, you'll look into some specific greenhouse gases. So the greenhouse effect is this idea where we have energy from the sun traveling through space, hitting the Earth's atmosphere, and then we can trace where this energy goes. So some of the energy bounces right off of the atmosphere, reflected by the atmosphere. Some gets through to the Earth, but then is reflected by the Earth. And then some is absorbed by the Earth's surface. And when that happens, it warms the Earth. And so it's like this light energy gets transformed into, it's an energy transformation. It gets transformed into heat energy, which we also call infrared energy or infrared radiation. So that heat then comes back off of the Earth. And again, some of it escapes right out the atmosphere. But some of it is also reflected back down by clouds or by molecules in the atmosphere, or is absorbed by molecules in the atmosphere, and that heat stays in the atmosphere. So the greenhouse effect is just that some of that energy coming from the sun is reflected back or absorbed by the Earth as heat. You have probably experienced something like the greenhouse effect. Thinking of a hot summer's day, perhaps you left your car outside and you probably noticed that it got way hotter inside your car than it even is outside, right? And that's because of the exact same thing, the greenhouse effect. Light energy comes in, it's turned into heat or infrared energy, and that infrared energy can't go through the windows the same way that the light can. It's trapped inside. So that's the same thing, greenhouse effect. I think one of the most interesting things to look at when it comes to the greenhouse effect is other planets' atmospheres and what that means for temperatures on their planets. So for example, on Mercury, they have a very, I don't know who they is, they have a very thin atmosphere because there's little gravity on Mercury. It's a small planet. It can't hold an atmosphere. So think about what the temperatures might be like on Mercury because of their thin atmosphere. There's a huge temperature range on Mercury from 800 degrees Fahrenheit to negative 270. So keep in mind the greenhouse effect also prevents our planet from getting too hot, right? When the sun's shining directly on Mercury, it's crazy hot. And then when the sun goes away, there's no gases to hold that heat in, so it gets very, very cold. So the greenhouse effect really is a good thing. The natural greenhouse effect is a good thing. We could not have life on our planet without it. But it's sometimes good to talk about the enhanced greenhouse effect, or the human-caused greenhouse effect is where it becomes problematic, right? Let's look at Venus. Venus, you might know, has a very thick atmosphere, and as well as being thick, it has a lot of carbon dioxide. I forget the percentage of carbon dioxide on Earth. You just did this last week. What is it? Do you remember? It's a very small percentage, but 96% of it on Venus is carbon dioxide, which is a greenhouse gas and traps heat. So Venus does not have a very big temperature swing at all, the opposite of Mercury, but it stays very, very hot there all the time, 872 degrees on average. They actually think that Venus used to be a lot more Earth-like, and that its atmosphere was a lot more Earth-like, and they had what's called a runaway greenhouse effect, where feedback loops made more and more greenhouse gases in the atmosphere. I think we talked about that. The natural greenhouse effect is good. The human-caused greenhouse effect is warming our planet. in a bad way. So as you can imagine, as you probably know, as we put more carbon dioxide into the atmosphere, which is not the strongest greenhouse gas, as you'll learn in this lesson, but definitely the most common greenhouse gas that is warming our atmosphere and enhancing the greenhouse effect.